How's it going, guys? Jumping into 612, linear partial fractions. Today we're going to talk about a way to solve these integrals that would not be solvable using U substitution or any other method. Well, I guess they could be, but this is a method that's going to save you some time. So what I want you to do is remember back in middle school how you would add two fractions with uncommon denominators. Let's say, for example, 2 over 3 plus 4 over 5. I taught you guys the butterfly method, which is just a faster way of doing what I'm about to show you, is multiplying both the opposing fractions by the denominator. So this 2 over 3, we're going to multiply this by 5 over 5. And this 4 over 5, we're going to multiply this by 3 over 3 so that we can arrive at a two fractions that have the same denominator. So 10 over 15 plus 12 over 15. And now we can add these together to get 22 over 15. Likewise, if this was not a number, if this was a polynomial expression, say 2 over x plus 3 and 4 over x minus 5, for example, we would have to do the same thing. We would have to multiply the opposing denominator over itself. So this left side, we have x plus 5, we're going to multiply that, x minus 5 here, and I'm going to put this in parentheses here. And over here, we need to multiply by x plus 3. Okay, so I'll leave the denominator factored because there's no need to multiply those two together. We can just leave it as x plus 3 times x minus 5. For our numerator, let's go ahead and distribute these because these can combine the like terms. So 2x minus 10 plus 4x plus 12. And this simplifies down to x plus 3, x minus 5 in the denominator, and 6x plus 2 in the numerator. Okay, so I wanted to review that with you because in order to solve partial fractions, we need to do what's called partial fraction decomposition. We need to take this kind of expression where we have two linear factors in our denominator and split it up so that we get these two separate fractions that are being added to each other. So that process is called partial fraction decomposition. Okay, and it works like this. So say for example, our numerator is 1, and our denominator is, I'll just choose two numbers like the ones here, x plus 3 and x minus 5, for example. We know that any fraction that has these two factors multiplied in the denominator can be split up into separate fractions where each fraction has that unique denominator. So I can split this up into some number, let's call that capital A, over x plus 3, and some other number, let's call that capital B, over x minus 5. Now just like before, we would need to multiply x minus 5 over x minus 5 by the first fraction and x plus 3 over x plus 3 by the second fraction to arrive at this middle step here. So let's do that. So multiply this by x minus 5 over x minus 5. You won't need to write this out each time. I'm just doing it now to show you how this works. Okay, so multiplying those gives us a new set of numerators. The first one's going to be a times x minus 5 plus b times x minus x plus 3 all over our common denominator, x plus 3 times x minus 5. Okay, so if we ignore this middle step here, we can see that since our denominators on the left side of this equation and the denominators on the right side of this equation are the same, and there's an equal sign throughout, that means that our numerators are the same, and we can ignore the denominators. And this is, well, one of the first steps of partial fraction decomposition. So we're going to take these two values that I've highlighted in green and set them equal to each other. If we take our numerators, we get 1 equals a times x minus 5 plus b times x plus 3. Now we need to find out what a and b are. So what we're going to do is we're going to select the values of x that will make each term cancel out. In this case, the first value of x that we're going to use is 5 because 5 minus 5 is 0. That'll make this entire term go bye-bye. So let's let x equal 5, and then we can say 1 equals, well, plugging in 5 here is going to give us 0. I'll write it out, but you don't need to. So 5 minus 5 plus b times 5 plus 3. And like I said before, this is going to be 0, so this entire term cancels out. And we're just left with 1 equals b times 5 plus 3. And 5 plus 3 is 8. So this is 8b, b times 8. So therefore, b is 1/8. Doing the same thing on the other side. Let x equal -3, because when we plug in -3 here, this b term will cancel out and we're left with 1 equals a times -3 minus 5. 1 equals a times -8. So a is -1/8. Okay, so here, our first question, we have 1 over x squared minus 49. This is a classic difference of squares. So we can definitely rewrite this as the integral of 1 over x plus 7 and x minus 7 dx. And just like before, because our denominator is a product of two linear factors, that means we can rewrite this as the sum of two distinct fractions. So I'm going to rewrite that. Again, as you do more and more of these, you won't need this intermediate step. X equal 7. That'll give us 1 equals, well, if x is 7, this cancels out, and we're left with b times 7 plus 7. And a little bit of algebraic manipulation, you'll determine that b is 1/14. So let x equal -7, then 1 equals a times -7 minus 7, and plus, well, the b term cancels out, so we're left with a is negative, well, 1/14. Okay, so that means that we can rewrite this integral as the sum of two separate integrals because we now know what a and b are. So I'll write that up here in green. I'm going to use a and b again. So this is going to be the integral of a over x plus 7 dx plus the integral of b over x minus 7 dx. So we're going to solve these two independent integrals down here. Okay, for this, you might need a u substitution, but you should be able to do this by now. If you're in Calc BC, you should already know the integral of 1 over x plus 7 is just the natural log of the absolute value of x plus 7. Same thing, 1 over 14, natural log of absolute value of x minus 7 plus c. Now you could leave it like this. If you look at the answer key, it looks a little bit different. So I'll show you how to go from this correct answer to the answer in the answer key. If you factor it out 1/14th, you get 1/14th times, and notice this first term is negative and the second term is positive. So if we switch the order, that just becomes natural log of x minus 7 minus natural log of x plus 7 plus c. And then if you remember your log rules, when you subtract two logarithms, what you're really doing is you're dividing the arguments. So that gives us 1/14th times the natural log of the absolute value of x minus 7 over x plus 7 and plus c. Okay, so let's check the answer key. Yeah, there it is. Okay, let's tackle number 2. Again, just to save on writing, I'm gonna jump straight into the partial fraction decomposition here. Okay, again, because our denominators are the same, we can now set 2x equal to this stuff up here, a x plus 2 plus b 2x minus 1. Okay, so let's let x equal negative 2. Therefore, left side 2 times negative 2 is negative 4 equals, well, that term cancels out. I'm left with b times 2 times negative 2, which is negative 4, minus 1, which is negative 5. So b is 4/5. Let's let x equal a half, because a half of 2 is 1 and 1 minus 1 is 0. That'll allow this b term to cancel out. So therefore, if x is a half, that means 2 times a half is 1 equals a times a half plus 2. 2. So therefore, a is 2/5. All right, now we can solve our integral, or rewrite our integral as the sum of two integrals. Dx. And now we're going to integrate. So we can take the constants out, pull the 2/5 to the front, and the integral, I'll write it out, integral of 1 over 2x minus 1 dx plus 4/5 integral 1 over x plus 2 dx. Okay, I'll use this opportunity to remind you how to use a u substitution to solve this integral here in green. So I'll write it again. So set u equal to 2x minus 1. That means du is 2 dx. Divide both sides by 2. We get dx equals du over 2. So it means we can rewrite this as the integral of 1 over u times du over 2. And we can pull that 1/2 out to the front. That gives us 1/2 times the integral of 1 over u. And the integral of 1 over u is just natural log the absolute value of u. And we know u is 2x minus 1. So we can bring that on back here to get our final answer, 2/5 times 1/2 natural log absolute value of 2x minus 1 plus 4/5 natural log of absolute value of x plus 2 plus c. Okay, so all they did in the answer key was they simplified this here and changed this into a 1/5. Okay, so that's how you solve the indefinite integrals using partial fraction decomposition. I'll leave question number 3 for you. Let's look at question number 4 where we have a definite integral. Uh, the same rules apply. We're just going to rewrite our integrals and bring over the limits of integration. Let x equal -1. Again, we're just taking the numerators here. Right? Once you have done this step, we just need the numerators. The denominators are not required at this step. So if x is -1, let's plug that in here. -1 minus 1 is -2 equals a times -1 plus 1. Not 0, it cancels out. So b times -1 minus 2, which is -3. So b is 2/3. Now for the other side, let x equals 2. So plugging in here, 2 minus 1 is 1. Again, I'm choosing the left side of this equation from here. 2 minus 1 is 1 equals a times x plus 1, so 2 plus 1 is 3, plus b times 2 minus 2 is 0, so that is cancels out. We don't need that. So we can see that a is 1/3. Okay, so now let's rewrite our integral as a sum of two different definite integrals. A, which is 1/3, over x minus 2 dx, plus integral from 0 to 3 of b, which is 2/3, times, 2/3 over x plus 1 dx. Pulling these constants out, we get 1/3 integral from 0 to 3 of 1 over x minus 2 dx, plus 2/3 integral from 0 to 3, 1 over x plus 1 dx. Taking the integral of these gives us 1/3 natural log of absolute value of x minus 2 plus 2/3 natural log of x plus 1. Now we're not going to do plus c here because these are definite integrals. So what you can do is put this entire expression in square brackets, and then on the right side we can put a 0 and a 3 here to remind us that we're solving this definite integral now. So again, let's remember that we're going to plug in the top number first, 1/3 times the natural log of 3 minus 2, plus 2/3 times the natural log of 3 plus 1. And then we're going to subtract, and then now we're going to plug in the bottom number, 1 over 3 times the natural log of 0 minus 2. Sorry, absolute value. I was about to say that you can't have the natural log of a negative number. Natural log of the absolute value, 0 minus 2, plus 2/3 times the natural log of the absolute value of 0 plus 1. All right, now 3 minus 2 is 1, natural log of 1 is 0, so this cancels out. Nice. Natural log of 4, that's a number. I'm just going to leave it as that. So we have 2/3 natural log of 4 minus natural log 1/3 natural log of 2. And again, here we have natural log of 1, which is 0, so that term cancels out. We use the natural log rules to rewrite these as natural log of 4 to the 2/3 minus natural log of 2 to the 1/3, which can be written as natural log of 4 to the 2/3 over 2 to the 1/3. Now 4 is just 2 squared, so this is really natural log of 2 squared to the 2/3, so we can write this as 2 to the 4 over 3 over 2 to the 1/3. And then we just subtract our exponents in the numerator. 4/3 minus 1/3 is 3/3. So this is the natural log of 2. Number 6, because we have 3 linear factors here. So we can split this into 3 separate fractions. To get our numerator, we need to multiply each one of these individual fractions by the linear factors that are missing. Now, since our denominators are all the same, all we really need is to compare the numerators. So let's first let x equal 1. So that's going to give us 2 equals a times 1 plus 2 times 1 minus 4. It's going to give us a times 1 plus 2 times 1 minus 4. And if you notice, the b and the c will cancel out because when we plug in x equals 1, this entire numerator becomes 0 and this entire numerator becomes 0. So we can just work from here. Negative 2/9 integral of 1 over x minus 1 dx, 1 over x plus 2 dx, and 1 over x minus 4 dx. Okay, so almost done. Negative 2 over 9 natural log absolute value of x minus 1 plus 1/9 natural log absolute value of x plus 2 plus 1/9 natural log absolute value of x minus 4 and plus c. Now, this is correct. We could leave it like this. Let's check the answer key to see if they have a different format. No, they left it like that, which is great. Okay, hopefully this was helpful, and see you when I get back.